Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई और MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ाया पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें फर्मी थ्योरी ऑफ बीटा डीके एंड द सिलेक्शन रूल्स ए विषय पढ़िबा देखो बीटा डीके बा बीटा पार्टिकल जते बेले बाहरुची जे कोनसी रेडियो एक्टिव न्यूक्ली रु तार मेजर्ड हाफ लाइफ रहउची वेरी करची 10 टू द पावर -3 रु 10 टू द पावर 16 ओके -3 टा एटा सेकंड रे 16 टा एटा इयर्स रे ओके सो एति की पर्यंत पूरा रेंज रे वेरी करुची यार हाफ लाइफ नाउ द लार्ज हाफ लाइफ of this beta radioactive nuclei are against the existence of electrons in the nucleus. Okay, so various types of beta decay can be classified by the orbital angular momentum which is carried out by the electron and neutrino by the parity change in the process. Okay, so এই ডিকে को आम क्लासीफाए करिपरिबा इन जनरल दुईटा वे रे गोटे हला GT, that is the Gamow-Taylor decay, where the intrinsic spins of the electron and neutrino are parallel. Agote hela Fermi decay, where the spins are anti-parallel. So for zero orbital angular momentum, which are carried off, having allowed transitions, and the decay constant increases roughly as the fifth power of the decay energy. So to explain these effects, the Italian physicist Enrico Fermi in the year 1934 से कौन कले गोटे theory formulate कले and the theory was very much successful for the beta decay purpose based on Pauli's neutrino hypothesis. Okay, and this theory is based upon the following assumptions. कौन कौन एठी हमें point wise देखिबा first कहूची जे the light particles which are electron and neutrino are created by transformation of a neutron into a proton in a nucleus and vice versa. Second point, the energy remains conserved in the decay process and the available energy is shared among the electron and the neutrino. And due to the larger mass, the product nucleus does not possess or does not receive any kinetic energy. Then third point, neutrino has rest mass 0 or very small, okay, as compared to that of your electron. Tapre fourth point, beta decay process is similar to the emission of electromagnetic radiation by an atom with electron neutrino field acting in place of the electromagnetic field, and the nucleons are the sources of light particles like electron, then antineutrino, positron, neutrino, which are similar to the charge at the source of photons in the case of your electromagnetic field. Okay, tapre fifth point, electron neutrino field is weak in contrast to the short range strong interaction which exists between the nucleons, जोटा कि nuclear force टा जोटा nucleus को bind करके रखुची वा बांधी रखुची. Then sixth point, the time dependent perturbation theory is a very good approximation. एटा जो एठी quantum mechanics apply करिवो स्क्रोडिंजर इक्वेशन यूज करके आम आपको देखा. सो ये आम टाइम डिपेंडेंट परटर्बेशन थ्योरी अप्लाई करवा व्हिच इज वेरी मच गुड approximation because of the smallness of the coupling constants or exceptionally weak nature of the interaction. Then seventh point, no nuclear parity change occurs and higher order terms in R by lambda can be neglected. And eighth point, the nucleons move the velocity of c by 10 light velocity ro 10 bhagaru bhage in the nuclei, and calculation can be made with non-relativistic nuclear wave function. Okay, so ସେଥିପାଇଁ ଆମେ ଏଠି non-relativistic calculation କରିବା. Now, using the Dirac expression for the transition probability per unit time of an atomic system to emit photon using the time dependent perturbation theory, the probability that an electron of momentum between PE and PE plus DPE is emitted per unit time, or you can say per second, may be written as PPE DPE, which is equal to 2 pi by h cross then mod of HIF square dn by de0. এটি dn by de0 ହେଉଛି number of quantum mechanical states of the final system per unit energy interval, and here HIF is the matrix element of the potential or interaction relating the initial and the final states. Remember, I for initial, F for final, and this is causing the transition. Now the former माने जो de by dn by de0 याको आमे गोटे statistical factor कहि परिबा which determines the shape of the beta spectrum, and the later जोटा HIF relates the electron and neutrino which are being emitted in order to associate the transformation, right? Now interaction matrix element HIF को एबे हमें यदि define करिबा, it is written as integration psi f star star माने एठी हमें complex conjugate नीचू wave function रो psi f star h psi I d tau. Okay, psi f और psi I हेगला wave function जेमति कहली for the final and the initial state. H हेगला एठी Hamiltonian operator which is describing the weak interaction between the two states. और d tau एठी volume element. Okay, so एठी देखो figure रे तुम देखिया को पाउछो इनिशियल स्टेट रेट अछि psi I. ओके, तापरे फाइनल स्टेट केमती आछि एठी डॉटर न्यूक्लियस टा जोटा प्रोडक्शन आछि एथिरु तमे देखिया को पाउछो रिकॉइल होउछि, तापरे इलेक्ट्रॉन एई दिगरे जाउछि आ गुटे एई दिगरे एंटी न्यूट्रिनो जाउछि. Okay, so that we are getting the final state wave function psi f. Okay, so this is the case of your beta decay process. Okay, similarly beta plus decay भी हमें आपको देखिबा जो थरे कि तमे positron आउ न्यूट्रिनो पाइबो. से जा भी हो for the negatron decay जेमति कहली here neutron is giving you a proton plus electron plus anti-neutrino. Okay, and here psi I is the wave function for the parent nucleus, which is here psi f, which is the wave function for the daughter nucleus, plus electron plus anti-neutrino. A सबू wave function रो product. Okay, एगला psi f, psi e, psi nu bar. Okay, एठी psi I जेमति कहली एटा होची parent nucleus पई wave function. Now we do not know the form of the interaction operator जोटा Hamiltonian H रो form टा कोन हमें जानिनु, but Fermi suggested a new constant which is called as the Fermi coupling constant, which is denoted by G, and is also represented by beta in some of the books. So it determines the strength of the beta interaction, and this universal constant G has a value about 0.9 into 10 to the power minus 4 MeV FM cube. Okay, and it is analogous to the electron charge E in the photon decay theory, and its character resembles that gravitational constant of the fine structure constant here when expressed in dimensionless terms, and moreover the emission of a neutrino and the absorption of an antineutrino of opposite momentum eta purapuri saman rahebo, they will be equivalent and can be replaced with psi nu bar star by psi nu. Remember? Okay, so complex star real हेगला केवल anti particle जोटा थिला nu bar एटा हेगला particle nu. Okay, in order to make the equation more symmetrical, thus the matrix element is written now as ऊपर जो हमें equation देखिथिला ताको एबे हमें ए हिसाब लिखि परिबा g integration psi f star psi e star psi nu कहीं हेला because psi nu bar star एठी थिला. राइट ये जगह sin nu बार स्टार ही था जोटा कि इक्वल टू sin nu आम लिखला तापर गोटे टर्म आछी m which is a dimensional matrix element ओके एटा भी गोटे ऑपरेटर तापर psi I जोटा होची parent nucleus पाई out d tau which is the volume element. Now since the neutrino interacts very weakly with the nucleus, so it is reasonable to assume the neutrino waves undistorted. Okay, এটা বেশি কিছু ইয়া উপরে এফেক্ট করিব নাহি, so they will be undistorted by the nuclear potential and may be taken as a plane wave with propagation constant, let us say k equal to p nu by h cross. So ଏବେ ଆମର wave function for the neutrino ହେଇଗଲା sin nu equal to v to the power minus half exponential of minus I by h cross p nu dot r. Okay, and for the light nuclei, here the electrons with kinetic energy greater than 200 keV, the effect of Coulomb field of the nucleus upon the ejected electrons can also be ignored or neglected, and the electrons here the waves may be taken again as plane waves. Okay, electron wave को हमें एठी plane wave हिसाब रे नेला psi e equal to v to the power minus half exponential I by h cross p e dot r. Okay, and here v is the whole volume in which the enclosure is there. Okay, we enclose the total system for the normalization process. A p nu p e ହେଇଗଲା momenta. Okay, momenta କାହାର neutrino ଆଉ electron ର respectively. ଆଉ ଗୋଟେ ଜିନିଷ ଅଛି ଏଠି r ହେଇଗଲା position coordinate. Okay, now here we have neglected some of the things like spins, as the magnitude of the wave function sin nu and psi e at the position of the nucleus are certainly much larger for the s wave neutrinos, and the electrons also it will be there. So for these particles with larger orbital momenta हमें actually spin को से हिसाब रे neglect कर देला because larger orbital momenta angular momenta रहुची. Okay, thus the matrix element becomes now HIF. एठी एबे हमें सब वैल्यू गुडा को पुट करिबा. Okay, so HIF equal to G integration एठी psi f star as it is रहिला psi I as it is रहिला m और d tau as it is रहिला मझी रे हमें रिप्लेसमेंट आनी देला. Okay, हमें पुट कला psi e और psi nu रो वैल्यू. Okay, now exponential factor जो गुटे एठी आछी within the curly bracket याकू हमें लेखि परिबा by an expansion of a power series about the origin r equal to 0 हिसाब रे हमें power series expansion लिखि देला. Now the nuclear wave function have appreciable values only in region of the order of nuclear dimension. Okay, so the significant value of r are no greater than that of your nuclear radius r. Okay, nuclear radius ରୁ ପାର ହେଇଗଲେ ଆଉ କିଛି ବି ତାର मतलब ନାହିଁ. So if p e p nu are both of the order of magnitude of MEC. Okay, okay, MEC माने electron mass सहित आम प्रोडक्ट करछु light रो velocity, right? So as it is usually in case of your exponent where it will be of the order of 2 MECR by h cross, which is nearly equal to 1 by 50. So this small value suggests that we need to retain only the highest term. Okay, highest term is जो expansion रो केवल रहिबो which is nothing but unity in the power series. So when this term is inserted in the above equation, the matrix element is now non-vanishing and it is no longer depending upon the energy or momentum of the light particles. So it is giving us allowed transitions. Okay, and the matrix element for the forbidden transition will be the energy dependent as they contain some of the terms of the form of Pe dot P nu dot Pe plus P nu dot R. Thus, for the allowed transition, the above equation can be written as HIF equal to G by V integration simplify ହେଇଗଲା psi f star m psi I d tau. ଏହି integration को हमें simply गोटे लिखि परिबा mod of MIF, which is nothing but the overlap integral of the nuclear matrix element of the final and initial wave function of the nucleus. And this can only be computed or calculated in a few cases where the structure of the nuclei is reasonably well known. Okay, now statistical factor বা फाइनल स्टेट डेंसिटी को एबे देखिबा हमें एच आई एफ बाहर कर देला एबे जीवा फाइनल स्टेट डेंसिटी डी एन बाय डी ई जीरो ओके हमर मेन टास्क है ये सब क्वांटिटी को बाहर करके हमें लास्ट रे फाइनली इक्वेशन रे पुट करिवार अछि सो स्टैटिस्टिकल फैक्टर actually it is indicating us nothing but the density of the possible final states in the phase space of the electron neutrino field, and this can be derived with the help of Heisenberg uncertainty relation. Okay, so the position momentum आमे जानिचो Heisenberg uncertainty principle हिसाब रे we cannot be certain about both of your position and momentum. So the position and momentum of the electron or neutrino can be represented by a point in the phase space. Okay, phase space মানে কোন? It is the space containing the three spatial মানে position or three momentum dimension. So the uncertainty principle prevents us from representing a moving particle by a single vector যেমতি কইলি. So this is because such a representation would amount us to specify both position and momentum exactly, which is not possible. Okay, so in the six dimensional phase space which is defined by xyz px py pz, the state of a particle cannot be defined to a greater precision than that of as indicated by the volume element, so which is called as the cell. Now since here এটি আমি যদি ইউনিট সেলর ভলিউম নেবা তাহলে del x dot del y dot del z dot del px dot del py dot del pz is nearly equal to h cube beta আমি জানিছু okay phase space ru. So the state of a system cannot be specified more closely than by saying that the tip of the vector representing it lies in one of these cells, and the states available to a free particle are distributed uniformly in the phase space with a density that is এটা ইনভার্স হয়ে গেলা ভলিউমর reciprocal হয়ে গেলা তোমার এটি density, so h to the power minus 3. Thus the number of states of a particle which is restricted to a spatial volume v and whose momentum lies between p and p plus dp without any regard to the direction in which the particle is moving is given by dn. a number यार वैल्यू है v जोटा कि पोजिशनल वॉल्यूम आउ 4 पाई p स्क्वायर dp एटा आसुची कोन एटा होउची दुईटा स्पियर मन कर गोटे स्पियर रेडियस हे गला p आ गोटे स्पियर रेडियस हे गला p प्लस dp बोथ ऑफ देम आर कॉन्सेंट्रिक ताले दुई स्पियर मझी एरिया ओके मझी एरिया को कंसीडर करो तार टोटल वॉल्यूम ओके और यू कैन सिंपली से गोटे स्पियर जदि रेडियस होउची p और थिकनेस हला dp ताले सरफेस एरिया होची 4 पाई p स्क्वायर इनटू थिकनेस इज योर dp. सो एटा आसी गला तमरो मोमेंटम वॉल्यूम. Okay, so divided by h cube हो गला right. This is giving you the number. Now this number of states corresponding to the appearance in volume v of the electron with the momentum which is lying in the range pe to pe plus dp is therefore given by dne, which is equal to 4 pi v pe square dp by h cube. And since the neutrino hardly interacts with the surrounding and may therefore be considered as a free particle once it is created, so the number of states for the case of your neutrino with momentum p nu and p nu plus dp nu similarly can be written as dn nu equal to 4 pi v p nu square dp nu by h cube. Okay, and as the electron and neutrino are independent of one another, so the number of states available to them jointly is given by the value that is dn equal to here 4 pi এই দুইটার প্রোডাক্ট করে দেবা 4 pi vp square dp by h cube into 4 pi vp nu square dp nu by h cube, and this denotes the number of accessible states in the phase space of the electron neutrino field. Okay, so number of states per unit energy जोटा हमको दरकार थिला dn by de0 यार वैल्यू केते हबो ए जो वैल्यूटा हमें पाइछु ओके जस्ट दिस वैल्यू डिवाइडेड by de0 राइट ताले total available energy here the overall decay energy जदि हमें एठी नहीं गला E0 is shared between the electron and the neutrino, therefore E0 को हम लिखि परिबा E plus E nu, and now we have ignored variation of the endpoint energy due to the small difference in the recoil energy of the daughter nucleus. Thus for a fixed electron energy dE we have dE0 equal to dE nu. मने रख एठी इलेक्ट्रॉन एनर्जी को हमें नियरली फिक्स्ड नौचु. Okay, so that differentiate color dE0 equal to dE nu hela, right? So here the momenta Pe and P nu are related to the electron and neutrino energy respectively by the equations. एटा तमरो आछि दुईटा इक्वेशन जोटा कि तमे relativistic mechanics बा special theory of relativity रे पढिथिबो. गोटे हला E square equal to Pe square C square plus Me square C4. okay, आ गोटे आसला E nu equal to Cp nu. एटी Cp nu कहीं है बिकॉज एटा E nu square यही भाया इक्वेशन आसता E nu square equal to P nu square C square plus M nu square C4 होता किंतु M nu आमे एठी 0 नहीं जिबा बिकॉज आमे एज्यूम करिचु जे न्यूट्रिनो मास होची 0. ओके, एटा आमे इनिशियली एजम्पशन रे ऑलरेडी नहीं सारचु. ताले DE nu will be equal to C dP nu. ओके, यही सबू को एबे हमें ऊपर जो इक्वेशन पाइथिला dN by dE0 सेठी हमें पुट करिबा. नाउ एबे हमें कोन करिबा जो स्टैटिस्टिकल फैक्टर आ HIF भी पाइथिला ताकू पुट करिबा PPE DPE. एटा होची प्रोबेबिलिटी. ओके, प्रोबेबिलिटी जगह रे एबे पुट कर देले हमें फाइनली यार वैल्यू पाउछु केते G square MIF mod square by 2 pi cube C cube H cross to the power 7 E0 minus EE square into PE square DPE. okay, किंतु एतिकी प्रोबेबिलिटी पाइला परे मध्य फर्दर इट नीड्स सम ऑफ द करेक्शन. गोटे करेक्शन हला एठी Coulomb correction, because while deriving the above expression we have not taken into account the Coulomb interaction, which can be neglected only for the light nuclei for which the atomic number is less than 10 and for sufficiently high electron energy. Now if this restriction is relaxed, the plane wave for the emitted electron must be replaced by the distorted Coulomb wave function. okay, if correction द्वारा आसीबा एबे कोन distorted Coulomb wave function, and this can be taken into account by multiplying the factor psi e mod square with a factor sometimes which is called as the Coulomb factor capital F Z E E. It is also known as the Fermi function. okay, so Fermi ru eta यार symbol एठी आछि capital F, and it is the ratio of the electron density at the daughter nucleus to the density at infinity. So mathematically we can write it like this. okay, infinity रे eta free हे गला एठी Coulomb, right? So this is fairly complicated, and in a non-relativistic approximation its value is nearly equal to 2 pi eta by 1 minus e to the power minus 2 pi eta. एठी eta कोन eta होची Z e square by 4 pi epsilon 0 h cross nu for the case of electron, and its value is similar but with a minus symbol for the case of your positron, right? Z हेगला एठी एटॉमिक नंबर प्रोडक्ट न्यूक्लियस रो एठी एटा टिके एठी करेक्शन देखो एटा न्यू नुह एटा होची v हला एठी velocity of the electron. okay, so better you should be acquainted with all these values, right? Now that velocity v is of that of your electron, and it is at a great distance from the nucleus, so that FZEE is greater than or equal to 1 for beta minus emission, and its value is less than equal to 1 for beta emission. So when consideration is given to this effect, that is your Coulomb correction, then above equation जोटा हमें पाइथिला PPE DPE एथिरे एबे हमें एसोसिएट करिबा हमर Coulomb factor, ओके, बा Fermi function. तापरे तार वैल्यू को पुट करबा आगरु हमें कोन करबा केतेरा क्वांटिटी हमें कांस्टेंट अछि याको रिप्लेस कर देबा C square where C is equal to this much. Okay, so we can transform this into probability per unit time, that the kinetic energy of the emitted electron lies in the range TE to TE plus DTE using the relation ଏଠି electron energy, then ଏଥିରୁ ଆମେ ପାଉଛୁ P square C square plus M square C4, so that 2E DE ପାଇଗଲା, right? ତାପରେ E0 minus EE, okay, ଏଟା ଆମେ calculate କରିପାରିବା, right? So that in terms of kinetic energy हमें ये expression को लिखिदेला हमें probability ना a relation को हमें लिखि परिबा in terms of reduced momentum, that is P equal to P by MEC, and the reduced energy small w equal to EE by MEC square, okay, এই হিসাবে দেখো লেখা ହେଇଛି, right? So এটি G square another replacement, okay, এটা আসला reduced moment হিসাବରେ, similarly reduced energy हिसाବରେ ଆମେ expression ଲେଖି ପାରିବା. So the behavior of the beta spectrum at very low electron or positron energy can be obtained directly from the above relation, and Coulomb correction actually increases or enhances the probability of the electron emission, and it decreases the probability of the positron emission, especially at low energy. Okay, so you can see here in the figure एठी हमें डेंसिटी फंक्शन को नहीं ये जो y एक्सिस रे काइनेटिक एनर्जी को x एक्सिस रे ताले देखो हाई एनर्जी रे कूलम इफेक्ट किछि भी एते तार देखौनी, ओके, किंतु एज वी सी बीटा प्लस बा पोजिट्रॉन पाई एटा डिक्रीज करौछि, आ बीटा माइनस बा एठी इलेक्ट्रॉन एमिशन पाई एटा इंक्रीज करौछि, ओके, आ जदी कूलम इफेक्ट हमें कंसीडर करनो थांता ताले ए मझी रे हमरो ग्राफटा आसी थांता, राइट? सो ये जो हाई एनर्जी रे कूलम इफेक्ट कहीं की रहू नहीं ताको हमें एक्सप्लेन करि परिबा इन द फॉलोइंग वे. देखो कूलम फील्ड एक्सेलरेट्स द पॉजिटिव इलेक्ट्रॉन एंड डिक्लेरेट्स द नेगेटिव इलेक्ट्रॉन. Hence, positron spectrum has fewer slow particles and electron spectrum will have more slow particles than they would have in the absence of Coulomb correction. This is why. Okay, so classically, no positron will be expected to emerge below the barrier energy, which is Ze square by 4 pi epsilon 0 r, and the actual spectrum does not contain some low energy positron as a result of tunneling effect. Okay, so the relation for the low energy beta plus emission is identical to that for your alpha decay. So here the Coulomb energy correction FZEE will be equal to this much. Right? Now next point is the screening by atomic electrons. So in addition to the nuclear Coulomb effect, the electrostatic potential of the atomic electrons affect the shape of the beta spectra, and the scientist Ridge has tabulated and found the correction from 1.5 to 400 keV, and this effect reduces the probability of beta emission by a factor of about 2% for 50 keV beta minus ray at Z equal to nearly 50. So a correction को यदि हमें देखिए, it is increasing the Z, increasing as Z increases or as beta minus ray energy decreases, and this effect is more important for the beta plus ray as it reduces the height and the thickness of the potential barrier. Okay, so the probability of beta plus emission is increased by about 37% at nearly Z equal to 50 for 50 keV beta plus range. Thus, the atomic electrons exert very little effect on the beta minus spectra, but affect considerably the emission for the low energy, which is less than 100 keV for the case of beta plus range, especially in a heavy elements. Okay, then we have the next, which is allowed spectra. एथिपाई हमें beta plus by beta minus ratio बाहर करिबा. So assuming the screening by atomic electrons as negligible, the ratio of the beta plus by beta minus माने positron to electron decay रो ratio जदि हमें बाहर करिबा ताले simply यार value put करिबा and this ratio is dominated by the exponential okay जोटा कि f z e रे अछि okay गोटे f plus आछि या गोटे f minus आछि so एथरे exponential जो term टा अछि सेटा ही dominate करूछि okay while all other energy dependent terms can nearly be cancelled okay so आमे लिखि परिबा p plus pe by p minus pe which is equal to constant then you have the exponential as I said तापरे exponential को हिसाब रे हमें लिखि देला ओके यदि ग्राफ पकोचो PPE against energy ए हिसाब रे देखो ग्राफ आसिला right okay so one is for the positron another is for the electron okay so एठी हमें गोटे देखि परिबा Wu and Albert using copper 64 source they found that experimentally and theoretically the curves are देखो एठी जो गोल गोल एठी हमें डॉट देखिया को पाउछु हैला एटा गोटे रिप्रेजेंट करछि आ गोटे सॉलिड लाइन जो देखिया को पाउछु एटा गोटे रिप्रेजेंट करछि ओके सो गोटे एक्सपेरिमेंटल आ गोटे theoretical curve okay so the experimental and theoretical curves between p plus by p minus and z e square by epsilon 0 h cross nu were in excellent agreement जोटा हमें ए फिगर रे देखिया को पाइला but slight variation होउची at the energy below 50 keV माने जेते बेले 50 keV रु टिके तळकु पळे आछी एठी देखो वेरिएशन टिके स्लाइड होउची okay as shown in the figure as this is possible due to the instrumental error maybe and this was the best test for the Fermi theory in the light of beta ray spectra okay तापरे नेक्स्ट देखिबा क्यूरी प्लॉट देखो आ गोटे बढ़िया कन्वीनियंट वे फॉर प्लॉटिंग द एक्सपोनेंशियल data and checking with the theoretical data this was suggested by Curie in the year 1936 so ऊपर जो हमें इक्वेशन 40 पाई थिला ताकू जदि हिसाब रे हमें लिखिबा स्क्वायर रूट बनै कि ताले सिंपली ए स्क्वायर रूट टा हे जिवो c into t0 minus te okay so t0 or te as we have seen these are the kinetic energy of the beta particles okay so a plot of the function on the left hand side of the above equation against te should be a straight line which is intersecting the energy axis at t0 এই equation रो हमें देखिया को पाउछु now this graph is known as the Curie plot okay that means here this will provide a good means of determining the maximum energy of the beta spectrum and maximum energy of the electron and positron which is obtained by Curie plots are 571657 keV respectively for beta rays which are emitted from copper 64 now many of the early Curie plots were non-linear at low electron energy and the derivation or the deviation at the low energy side are probably instrumental okay instrumental error may be ही पारे जेमति हमें ऊपर भी देखुतिला so this error can be caused by the electron scattering and the source due to the energy loss in the source material okay and if we take into account a relativistic mass correction ऊपर हमें देखुतिला जो non relativistic case consider करतिला यदि relativistic mass correction को introduce करिवा for the case of your neutrino then we see that Fermi plot nearly the end point energy is not a straight line okay so end point energy पाखरे Fermi plot टा straight line आसीबो नाही but टिके sharply ये turn करिवो in order to intersect the energy axis at a point smaller than the value for the zero mass neutrino okay so ए थ्रू हमें कॉन्सेप्ट बाहर करि परबा जे न्यूट्रिनो रो एक्चुअली मास को कंसीडर करबा को पड़िबो ओके देखो एठी आउची तमरो क्यूरी प्लॉट एटा जदि ओ स्ट्रेट लाइन आसिला ओके जदि जीरो मास थांता न्यूट्रिनो ताले पूरा स्ट्रेट लाइन हेतांता एंड रे किंतु एंड रे देखो टिके बंके जाउची ओके टिके स्लाइटली एठी बंके जाउची सो दैट हमको एठी न्यूट्रिनो रो मास कंसीडर करबा को पड़िबो so the rest mass of the neutrino can be measured with the help of this Fermi theory and the total disintegration energy in terms of the neutrino rest mass energy, which is given by E0 equal to EE plus E nu plus m nu c square. And here the maximum beta particle energy Emax is less than E0, right? Now using the relativistic energy momentum relation, P nu is equal to this much. Okay, now ଏବେ ଦେଖ ଏଠି ଆମେ ଇଲେକ୍ଟ୍ରନର ନ୍ୟୁଟ୍ରିନର ଆମେ ମାସ୍ କନସିଡର କରିଛୁ, so that m nu ଆସିଯାଇଛି, right? So the probability distribution is now given by PPE equal to this much. Okay, right? Now this reduces the equation ଉପରେ जो हमें पाइथिला 37 for m nu equal to 0, right? And a great many experiments have been carried on the beta spectrum, and one of those scientists, Langer and Moffat, compared the precision measurement at high energy of the H3 spectrum. Okay, जोटा कि हाइड्रोजन पाई गोटे यार आइसोटोप. So spectrum पाई निया हला taken with high resolution magnetic spectrometer with Curie plots drawn for the case of your neutrino mass 0, 0.25, 0.5 and 1 keV, okay, which are shown in the figure, and the data are consistent with a neutrino rest mass of 0 and set an upper limit of 0.25 keV for a possible rest energy. Okay, so in the figure, which you can see, it is about 0.05% of the electron rest mass and can thus be assumed to be nearly 0. Okay, electron rest mass ro 0.05% मात्र आसुची. Okay, तापरे आ जने साइंटिस्ट Lubimov et al. They estimated the best fit value for the neutrino mass at 37 electron volt, and these results are inconsistent, however, with the experimental values. Okay, right? Now lifetime of beta decay. Okay, beta decay रो lifetime केमती आसीबो, जो ऊपर हमें इक्वेशन 37 पाइथिला एथरो हमें probability per second per unit time बाहर कला for the emission of an electron with momentum PE and PE plus DPE. Now the total probability per second যদি আমি এখন নিলাম lambda, then for beta disintegration it can be calculated from integration over all values of electron momentum, that is from 0 to P max. Okay, so lambda equal to हमें बाहर करछु log E2 by T half, which is 0 to P max of PPE DPE. We put the value, okay, जोटा constant अच्छी बाहर को हमें आनी आसिला, then the integration. So याको हमें लिखी देला with a replacement small f. Okay, right? So if here E0 is very greater than MEC square, or P max is very greater than MEC, then the Coulomb correction factor FZEE is nearly equal to 1, and the replacement small f varies roughly as E0 to the power 5. Okay, so to the power 5 rate variation asuchi, and this E0 to the power 5 dependence connecting lambda and E0 was first noticed by Sargent in the year 1933, and it is known as the fifth power law, which is obeyed in some cases, which are particularly by positron spectra of light nuclei. So for heavy nuclei, the distortion kaiki aseo because of the Coulomb field, which is more effective, and there is no simple analytical expression for small f. Okay, so comparative half life for a beta unstable nuclide is defined as ft half, which is usually written as ft. Okay, and the product ft depends solely upon the nuclear matrix element, as ft equal to will be 0.693 tau 0 by MIF mod square. Okay, tau 0 हो गला एटी new neutral constant, which is known as the universal beta decay time constant, and the substitution of the numerical value will give you tau 0 equal to nearly 7000 seconds, so that ft रो value आसीगला 5000 by MIF mod square. Okay, so this equation shows that the comparative half-life is proportional to the inverse square of the matrix element. Okay, ft is inversely proportional to the square of the matrix element, that is MIF, which depends upon the nuclear structure, and it is expressed in seconds and covers a very wide range of values, that is from 10 to the power 3 to 10 to the power 23 seconds, and it has been therefore found more convenient to use its logarithm. Okay, logarithm माने log ft हमें बाहर करि परिबा, so that the greater value of ft, then longer will be the comparative half life and smaller will be the probability of the radioactive change. Okay, next ଏବେ ଦେଖିବା ଆମେ classification of beta transition जोटा कि होची selection rules. देखो आमे ऊपर स्टार्टिंग रो पढ़िला जे बीटा डीके लाइफ टाइम एक्चुअली दुईटा कैटेगरी रे आसी परिबो, गोटे थिला गैमो टेलर आ गोटे थिला फर्मी. Okay, so accordingly transitions are broadly divided into those which are allowed and which are not allowed, or you can say forbidden. Now these transitions are governed by certain selection rules. Okay, so above theory is applicable when the electron and neutrino carry away no orbital angular momentum while leaving the nucleus. Okay, so nucleus को छाड़िबा बेलकू electron और neutrino किछि भी orbital momentum नेबे नहीं, and in fact if they are emitted with their intrinsic spins anti-parallel, that is singlet state, then the change in the nuclear spin, that is delta I, must be strictly equal to 0. And if these are emitted with their spins parallel, जोटा कि आमे कहबा triplet state, then delta I may be between three values plus 1, 0 or minus 1, but no I equal to 0 or IF equal to 0. माने एठी I रेफर करछि इनिशियल को और F रेफर करछि फाइनल न्यूक्लियर स्टेट्स को. ओके, सो द फॉर्मर सिलेक्शन रूल जो थे कि आमे सिंगलेट स्टेट देखुतला एंटी पैरेलल, इट वाज एक्चुअली ओरिजिनली प्रपोज्ड बाय फर्मी, एंड द लेटर जो थे आमे पैरेलल देखुतला ट्रिपलेट स्टेट, इट वाज actually suggested by Gamow and Taylor. So in both these types of allowed transition, the orbital angular momentum and the parity are left unchanged, and the interaction that give rise to Fermi and Gamow-Taylor selection rules are different. Okay, so the experiment shows that the allowed transitions of the type delta I equal to 1 obeying GT Gamow-Taylor selection rule are forbidden by Fermi F selection rule. As in the decay, let us see some of the example. एठी देखो helium आमे consider कला helium 26 giving lithium 36 with that of your beta minus plus anti-neutrino. Okay, then we have the change of the I, that is 0 plus to I plus, so that log ft हमें हिसाब रे 2.77. then carbon 614 giving nitrogen 714 with beta minus anti-neutrino 0 plus to 1 plus log ft 3.62. तापर टिके हेवी न्यूक्लियस जदि देखिबा जर्मानियम और आर्सेनिक भितरे ताले एठी हाफ माइनस टू 3/2 माइनस log ft हेगला 5, and there are also allowed transitions of the type 0 to 0, okay, which are allowed by F selection rule but forbidden by GT selection rule. For example, oxygen 814 giving nitrogen 714 with beta plus neutrino 0 plus to 0 plus log ft 3.487. Now the ground state of 714 nitrogen has a spin 1, however 2.31 MeV excited state যদি কি এটা গলা 714 nitrogen, okay, star পড়িছি মানে এটা হচ্ছে excited state has a spin 0. Okay, similarly other examples भी देखि पारो जोथिरे 0 plus to 0 plus होउची देखो ये वाला बहुत गुडा example देछि along with the log ft value. Now however many transitions are allowed by both selection rules. and this is always possible in the allowed decay, as in which I equal to IF but not equal to 0. Okay, so these examples एबे जदि देखिबा हमें simple example हला न्यूट्रॉन रू प्रोटॉन आछी with beta minus and anti neutrino half plus log ft value 3.074. Similarly hydrogen रू helium आछी beta minus anti neutrino half plus log ft 3.05, right? Similarly other examples जो थे भी तुम्हें देखिए पाओ 3/2 plus 5/2 plus, okay, log ft value similarly दे देला. So these allowed transitions are further classified as favored, जोटा कि हमें कहबा super allowed, and unfavored, only allowed transitions. Okay, so the allowed transitions is set to be favored by super allowed केतेले कहबा if the nucleon which changes its charge remains in the same level, and it is unfavored if the nucleon changes its level. Okay, so most of the allowed beta transitions are unfavored, okay, just allowed. And for the beta minus decay, the change of neutron into a proton without the change of the level would increase the total energy of the nucleus and would therefore not lead to a spontaneous decay. So for the beta plus decay, the surplus neutrons makes the allowed transitions unfavored, and these are few expressions. As you can see, hydrogen to helium, helium to lithium, carbon to boron, then fluorine to oxygen. Okay, now the condition for the super allowed transition gonna, these are same as that of the unfavored or allowed transitions, but the matrix element is also energy independent, and the main difference between the two states is that unfavored or simply allowed transitions are not between mirror nuclei. Okay, mirror nuclei unfavored have nahi. So in the case of super allowed transition, the decay probability is very high and log ft value is very low. So the mirror nuclei, like from carbon 11 to your titanium 43, okay, they have their half lives ranging from 1230 seconds to 0.6 seconds, and the corresponding Emax value, okay, maximum energy value is 0.99 MeV to about 5 MeV. So the values of the log ft are thus very close together. Okay, so the quality I may know you example transition nuclear decay transition, then T half Emax, which is in expressed in MeV, and log ft value. Okay, गुड़ाए example एठी देला. Okay, जो थे कि different category of transition एठी express करूची. Right, now let us now consider what happens when the transition from initial to final nucleus does not take place by emission of S wave electron and neutrino. Now because of the finite size of the nucleus, the electron and neutrino emission with orbital angular momenta, and this is actually other than 0 jodi ame nouchu, this is also possible. Okay, so the magnitudes of the wave function, that is psi e psi nu for p wave, d wave, etc., over the nuclear volume decreases rapidly with increasing the orbital angular momentum, and the beta transition with angular momentum which is carried by two light particles together. Here we have L beta equal to 1, 2, 3 dot dot dot, which are classified as the first, second, third, fourth, similarly so on, of your forbidden transition. So it L beta jodi odd hegala. Okay, if L beta is odd, the initial and final nuclei must have opposite parity. That means the parity changes in the age transition. Or jodi even hela, then they will have same parity, no change in parity above. Furthermore, as in allowed transition, the emission of lepton mane like your electron, neutrino, okay, in the singlet state mane eti Fermi selection rule lagila, requires delta I less than equal to L beta, whereas ट्रिपलेट स्टेट जो गेमो टेलर लागू सिलेक्शन रूल द एमिशन रिक्वायर्स डेल्टा I less than equal to L beta plus 1. Okay, thus the selection rule for the forbidden transitions are as follows. First forbidden, for those L beta equal to 1, parity changes, so it has chief Fermi selection rule de delta I equal to plus or minus 1 0 except 0 to 0. तापरे गेमो टेलर रूल रे डेल्टा आई इक्वल टू प्लस और माइनस 2 प्लस और माइनस 1 0 एक्सेप्ट 0 टू 0 हाफ टू हाफ 0 टू 1. ओके एटा हमरो फॉरबिडन आछी. तापरे एठी जदि आमे एग्जांपल देखिबा देखो गुडा एग्जांपल एठी फर्स्ट फॉरबिडन दे देला. ओके देन second forbidden where L beta is equal to 2 and no change in parity. Fermi selection rule कहूची delta I equal to plus or minus 2 plus or minus 1 except 0 to 1. Okay, गेमो टेलर कहूची delta I plus or minus 3 plus or minus 2 except 0 to 2. Okay, different examples are given here. Okay, तापरे similarly हमें third fourth similarly lth order forbidden रूल बा फॉरबिडन ट्रांजिशन आम पाइपर. सो आम जनरल फॉर्मूला है फॉर्मी सिलेक्शन रूल डेल्टा आई इक्वल टू प्लस और माइनस एल माइनस 1 आउ गेमो टेलर डेल्टा आई इक्वल टू प्लस और माइनस एल प्लस 1 एंड द पेरिटी चेंजेस फॉर एल इक्वल टू ऑड एंड इच डज नॉट चेंजेस फॉर एल इक्वल टू इवन. एटा आम ऑलरेडी जानिछु. नाउ the allowed and the forbidden nature of the transition is often determined by the ft value जोटा कि atomic number end point energy और half life period ऊपर depend करूची. आ एई ft value nuclear matrix element ऊपर भी किछिटा light पकेला and it is varying inversely as the square of the matrix element. Okay, so Lec-8 shows that one cannot easily divide them into clearly separated groups, but additional information हमें पाई परिबा from cell model, nuclear cell model consideration or from empirical spin determination. Okay, so it has made it possible to group corresponding to different orders of forbiddenness. Okay, so the region of large ft value in case of your forbidden beta decay. मन रखो forbidden जेतेबेले होउची ft value बढ़ी बढ़ी जाउची. काहे की बढ़ी बढ़ी जाउची? It comes from the fact that with L greater than 0 the emission of beta particles is inhibited due to the angular momentum barrier, and this results in a reduction of the nuclear transition matrix element and hence an increase in the ft value. So the larger the value of L, the larger will be the effect and the ft value will also be the larger. So nuclear matrix element jota MIF is very large, nearly equal to 1 for mirror nuclei, right? So as in case of your initial and final state nuclear wave function, they will be very similar and overlapping is nearly complete. So in case of your allowed transition, এটি কোন হবো overlapping of the wave function is far less and the matrix element is reduced, right? Now smallest value of these ft, these are found for a group of light nuclei for which this is ranging from 2.7 to 3.7, and the transition of this group is described as the favored allowed but super allowed transition. Another group of nuclides is found for which log ft is ranging from 4.4 to 5.8. याकू कहबा हमें normal allowed but unfavored transition. Okay, and the first forbidden transition by ft value, they will be 1000 times bigger. Rough calculation जे हमें देखिबा rough classification रे हमें याकू कैटेगराइज करि परिबा into ft values which are shown in a tabular format. Okay, देखो ft value को हमें log नहीं की. Okay, super allowed 2.7 to 3.7, allowed एगला 4 to 6, first forbidden 6 to 10, second forbidden 10 to 14, then 14 to 17, 17 to 24 एगला fourth forbidden and so on. Okay, so to obtain the ft values from the measured decay energies and half lives, it is convenient to use either the extensive graphs of log ft versus E0 and Z, which is published by Finberg and Trick, or monograph of ft half life, and E given by Mojoski. Okay, so one can use the approximate expression by using this formula for your beta minus and beta plus. There are two formulas. Okay, here E0 is the kinetic energy expressed in MeV, and Z is the atomic number of the product nuclide. Okay, now after this I have taken the Fermi theory of beta decay and the selection rule from one book. Now moving further, this I have taken from another book. ଏଥିମଧ୍ୟ ତମେ ଦେଖିପାରୁଛ ସେମ୍ ଜିନିଷ ଦେଇଛି जो बीटा डीके थ्योरी फर्मी थ्योरीटा. ओके, तापरे केतरा जिनिस एथिरे डिटेल डेरिवेशन मध्य करिछि. ओके, डेंसिटी ऑफ स्टेट्स देखो कैलकुलेशन कला. देन वी हैव द कूलम करेक्शन, जा द्वारा कि तमे एट द एंड ग्राफ पाइबो स्पेक्ट्रम रो शेप केमती कूलम करेक्शन रे चेंज होउछि फॉर बीटा प्लस एंड बीटा माइनस एज यू कैन सी. तापरे क्यूरी प्लॉट एटा. ओके, देन moving further, neutrino mass consideration, then allowed and forbidden beta transition को आसिला बा beta decay को. ओके, एथिरे मैथमेटिकल कैलकुलेशन ए बही रे देछि डिटेल वे रे. ओके, सो एटा भी तमे पढ़ी पारो. देन मूविंग फर्दर देखो, कमिंग टू द सिलेक्शन रूल. ओके, ऑलरेडी देछि सुपर अलाउड, अलाउड और फर्स्ट फोरबिडन पई लिखि देला वैल्यू गुडा जो एफटी रो, एनर्जी रो आउ टाउ रो. ओके, सेम जिनस जोटा हमें ऊपर मध्य देखौतिला. देन वी हैव द सिलेक्शन रूल एज आई सेड. ओके, ए विषय रे देखो एथिरे केदरा ज्योमेट्रिकल इंटरप्रिटेशन से हिसाब रे ये डिस्क्राइब करूची बाय यूजिंग द वेक्टर डायग्राम मेथड. ओके, सो दिस कैन बी आल्सो यूजफुल फॉर योर स्टडी पर्पस. ओके, एज फार एज द सिलेक्शन रूल इज कंसर्न. ओके, सो ए सब ट्रांजिशन को से डिटेल पॉइंट बाय पॉइंट बुझाऊँगी ए बही रे, टिके डिटेल अच्छी ए बही रे. ओके, सो आई एडवाइस यू टू रीड फ्रॉम दिस बुक ऑल्सो एंड मेक योर नोट as briefly as possible.
Thank you.